Okay, hopefully you're watching these intro and simple probability part two. Hopefully you're watching these videos before you do the practice stuff. The practice problem should end up being fairly straightforward if you take the time to watch these. Plus, I can see and give you credit for doing that. That'll be kind of like your classwork. So watching these videos is worth some classwork credit for you. And then the practice is going to be like homework. You can do the practice stuff more than once, so I'm going to be counting your scores on these. So if you don't do as well as you would like, um, do it again. And then you can get whatever grade you want on them if you're willing to put in the time. So you should watch these 3 videos here, and then we're going to do some practice ones. So I'm going to go ahead and go into this practice setup here, and you may not see these exact same questions, or you might see these questions. That all depends on what problems are pulling up here. Each and every time on these simple probabilities, I'm using this formula right here. And the notation, this capital P, is for probability, the probability of some event happening. So the event depends on what you're doing here. Here, we're rolling a 6-sided die on this first one, but the probability of getting a 1 or getting a 3 or rolling a 6, whatever, that's the event. And then the right side is just a fraction. On each of these, it'll ask me to put it as an answer to 2 decimal places, so we'll actually do the division, but you can use a calculator, and in fact they have a built-in one here if you don't have one handy. The number of ways an event could happen over the number of possible outcomes, and so you'll write it as a fraction and then just divide to get the decimal on that. So let's go ahead and get going on this first one. The first one, you roll a fair 6-sided die, and it wants to know the probability that you get a 2. So the probability of rolling a 2 on a 6-sided die. Well, there's 6 sides. So if there's 6 sides, that's 6 different things that could happen. I always do my denominator first because it seems like that's a straightforward number each time. The number of possible outcomes, well, there's 6 sides, so there's 6 possible outcomes. And we want to roll a 2. Well, if I roll a 6-sided die, I could get a 1, a 2, a 3, a 4, a 5, or a 6. This would be the number of possible outcomes. There's the 6. This is called a sample space. But it's really fairly straightforward. How many ways could I roll a 2? Well, only one way. There's only one way I can get a 2, and that's to get a 2. So there's one way out of the 6. So the probability of rolling a 2 is 1/6. Now I could leave it as 1/6 if I wanted, but it's going to be, here it says in the problem, round your answer to 2 decimal places. So I'm going to go ahead and divide that. 1 divided by 6. So if I do 1 divided by 6, I get 0.1 and then a repeating 6. And so it says to round it to 2 decimal places. So this 6 is going to round to a 7 because there's a 6 right after it. So the probability of getting a 2 is 0.17 if I round to the to 2 decimal places there. So I'm going to go ahead and type that in over here, 0.17, and check it. Yay, I got it right. So let's move on to the next one. And I'm going to clear out my problem here. And here we go. Let's read the question here. Jake is going to call one person from his contacts at random. Why? We don't know. He has 30 total contacts, and 16 of those contacts are people he met at school. So we know that 30 is the total, and 16 are the ones that he met at school. And it wants to know here, what is the probability, that he calls a person from school. So calls a person from school. And so it's always a fraction. The total always goes there. The total number of contacts is the 30. So there's 30 different people he could call. So that's the denominator. And then up in the numerator, it's how many ways could this happen? How many ways could he call a person from school? Well, 16 of his contacts are people he met at school. So there's 16 different people he could call that would be somebody from school. So that's my numerator. So 16 over 30, this probability, that event, I don't want to type it all over again, 16 out of 30, that happens to reduce. But I'm just going to do the division. I'm going to do, because it says it to 2 decimal places, I'm going to take 16 divided by 30. And 16 divided by 30, I get 0.53, and it's actually repeating 3, but I'm rounding it to 2 decimal places. So there's a 53% chance of him, slightly over 50%, because there's slightly more than half of them are from school. So let me put in that answer, 0.53. Hey, nice work. So now we have a circle graph of sorts, pretty simplistic one here. I'm going to clear that out, and let's see. You spin the spinner shown below. Each sector shown as an equal area. That's actually a pretty critical idea, that each of these slices are the same size. If they were not the same size, then it's not simple probability where they're all equally likely. But these are all equally likely. And then you spin the spinner shown, each sector shown as equal area. What is the probability that you get the spinner to land on a section that's labeled beaver? So the probability of it landing on a section labeled beaver, well, the total is always the quick and easy one. How many different things could happen when you spin this spinner? Well, I could spin it and hit the turtle like it's showing, but then there's 1, 2, 3, 4 others. So there's 5 slices. So my denominator is 5 because there's 5 slices or 5 sectors on this spinner. And then the number of ways that I could get it to land on the beaver one, well, there's 4 different ways that could happen. 1, 2, 3, 4. So 4 out of the 5 slices. So the probability of it landing on a sector labeled beaver is 4 out of 5. And as a decimal, that is 0.8. If you take 4 divided by 5, you get 0.8. So I'm going to use that as my answer, 0.8. On all these, it's saying a proper fraction or an improper fraction. So that an improper would not be an appropriate probability, but I could be leaving these as fractions. I'm putting them all as decimals. Let's see. You roll a fair 6-sided die. I'll just do it here. A fair 6-sided die. We want the probability that it's not a 5. Well, it's a 6-sided die again, so my denominator is 6. Remember, this is always the total possible. And so there's 6 sides. The denominator is going to be 6. But then if I think about how many ways could I get something that's not a 5? Well, when I roll it, I could get 1, 2, 3, 4, 5, or 6. And how many ways could I get it that it's not a 5? Well, 1, 2, 3, 4, 5 different ways. There are 5 of the results are not 5. So my numerator is a 5. 5 out of the 6 would be the total. So 5 divided by 6. And I get that this probability of not a 5, I took 5 divided by 6, and I got 0.83. The 3 is repeating, but I'm rounding it to 2 decimal places, so I'm going to go with 0.83. 0.83. 3. And look at me go. Next one, let's clear this out. Cam can't figure out what to eat. He is going to randomly select a piece of fruit from his pantry. There are 4 apples and 5 bananas in his pantry. What is the probability that he selects an apple? So we want the probability that he picks an apple. So he is randomly selecting a piece of fruit. So I need to figure out what is the total number of possible outcomes. Well, there's 4 apples and 5 bananas. How many pieces of fruit is that? That is 9 pieces of fruit. So he has 9 different things he could pick. He could pick the first, second, third, or fourth apple. But he could also pick the first, second, third, fourth, or fifth banana. So there's 9 possible things he could do. And then how many ways could he pick an apple? Well, there's 4 apples, so there's 4 different apples he could have picked. So it's going to be the 4 out of the 9, and 4 divided by 9 is a repeating 4. So the probability that he picks an apple is 0.44. And again, it's actually a repeating 4, but it says round it to 2 decimal places. So 0.44. And I am almost done. Next one here. You randomly draw a marble from a bag of marbles that contains 7 blue, 2 green, and 1 red marble. And here's just a visual of that. 7 blue, so 1, 2, 3, 4, 5, 6, 7. 2 greens, 1, 2, and then there's 1 red. The probability that not draw a blue marble. So the probability of getting something that's not blue. So we're randomly drawing a marble out of there, and the probability that it's not blue. But it doesn't really matter about the not blue for this denominator. How many marbles are in the bag? Well, there's 7 blue, 2 green, 1 red. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles. So my denominator is going to be 10. And then I need to put my numerator as how many ways could I get something that's not blue? Well, the ones that are not blue are the green and the red ones. So there's 1, 2 green, 1 red. That's 3 total that are not blue. So 3 out of the 10. And 3/10 is 0.3. So my probability is 0.3. And yay, let's do one final one. The probability that I get something that's not a squirrel here. So here you go. You spin the spinner shown, each sector shown is an equal area. The probability that it's not a squirrel. So the probability of not a squirrel. So the denominator, again, I always do it first. I just figure the total out. 1, 2, 3, 4, 5 sectors. There's 5 sectors on this thing. So my denominator is 5. And then how many of them are not squirrels? Well, caterpillar's not a squirrel, rabbit's not a squirrel, raccoon's not a squirrel, ladybug's not a squirrel. So 4 out of the 5 are not squirrels. And 4 out of 5 is 0.8 if you put it as a decimal. So it should be 0.8. And so I'll check that and look at me. I earned some energy points. Look at that, it's celebrating. If you didn't get a perfect score but want to get a perfect score, super easy. Just go to another section and go right back to the practice. It'll give you some different questions and you go through those and you should be able to get as high a score as you want. You can keep redoing it and get as many points as you want to get out of the 7 questions. So hopefully this helps you get a perfect score on that section.